Right, so welcome to 9.5. We're going to do problems we've already done before, but there's going to be more negative exponents in them. Right, so let's review what we've learned about negative exponents, right? Negative exponents make reciprocals. So when you get a negative exponent, you have to flip things over. So x to the negative 7 becomes x to the 7th flipped up to the top. Y to the negative third flips down to the bottom. Negative exponents flip things over, make reciprocals. So those are equivalent for any value of x. And so x to the negative third is 1 over x cubed. It works that way. Now the trickier one is this one. That coefficient is in the numerator and it stays. So that's 5 over x cubed. And this would flip up to the top and become x squared. So 1 over x to the negative second is positive x squared. Same thing here. The 7 stays down there, and the x to the negative first goes up there and becomes x to the first. That's x over 7. Okay, so we're going to do that today, but we're also going to have to simplify. We're going to combine two things we've already know. So, right, you would flip this up there, flip that up there first, then you cancel, right, and you get x to the first or x. Here, the 2 stays. The x stays because that's x to the positive 1. The x to the negative third goes up there. Then we have 2x times x cubed. That's 2x to the fourth. All right, so now, some of you may have noticed that we're subtracting here, right? This is x cubed, right? And it's x cubed, 25 minus 22. This is the way I taught you. Cross that out, make that 1 over x squared. But what is happening there is we are subtracting the top minus the bottom, which is x to the negative second. The problem is you can only have positive exponents in your answer. So doing the subtraction the way I showed up here really doesn't turn out to be the best way. Better to cancel than subtract, realizing that the x squared is in the denominator. All right, so what's going on here? 9 minus 9 is 0. Y to the 0 is 1. But if you have the same thing top and bottom in a fraction, as long as it's not a 0, it's 1. So, right, that's 1/5. Okay, it is also 5 to the negative 1. All right, so my suggestion is you do your flipping first, then you do your canceling. So that cancels, there's 2 left, 1 over x squared. X to the fourth goes to the top, stays at the top. X squared goes to the top. You're multiplying powers, you add the exponents. The y to the fourth stays, the y squared comes down here, and we have 1 over y to the sixth. Right? Coefficients do not ever get flipped. They're not part of the powers. They're coefficients. 5 divided by 5 is 1, 10 divided by 5 is 2. All right, so we have a 2 up there, an x to the fourth up there, and we're going to put an x squared up there, and we get 2x to the sixth. The 10 stays where it is, the x to the eighth stays where it is, the x squared goes down there, and we get 1 over 10x to the 10th. 5 and 7 stay. They can't be simplified. The x cubed stays, but this x to the negative 1 goes up there. The y to the fifth stays, and this y squared comes down here. This comes down there, and you get 5x to the fourth over 7y to the seventh. Right? Those, you can flip those over, but same thing top and bottom. As long as you don't have y equal to 0, you equal to 1. Right, so look at this. So if you have x to the negative fifth times x cubed, negative 5 plus 3 is x to the negative 2. But the problem is you're not allowed to leave that, right? So you have to flip it over and make it 1 over x squared. See another one of those. So you have -4. You have -4 plus -3 is -7. -2 plus 9 is +7. So can't leave it that way. The y to the 7th stays where it is. The x comes down here, and we get y to the 7th over x to the 7th. Now, with these, there's more than one way to do it. You could just flip this over right at the beginning, right? And think of it this way and cancel that way. You still get the same answer, and you could do that one that way as well. I think multiplying the powers and adding the exponents first and then fixing it in this particular case is better. So coefficients, 12 times 3, we actually multiply those. -6 plus 2 is -4. -3 plus 5 is +2. So the 36 and the y squared stay. X to the -4 goes down there. All right, now there's an exception, right? Powers, we don't leave negative exponents in our answer, but we do leave them for scientific notation. So this is where you actually subtract. So this is 9.6 times 10 to the 2nd divided by 3 times 10 to the 7th, right? So 9.6 divided by 3 is 3.2. Now, we have, right, we could cancel it, but that doesn't really help here, right? We have to do 2 minus 7. So this is 3.2 times 10 to the -5th, right? Because the fifth would be down here, right? And so that's 3 times 10 to the -5th. Better to think of it, this is where you want to subtract your exponents, 2 minus 7. So 8 divided by 2 is 4. So 9 divided by 2 is 4.5, or 4.5. And 5 minus 7 is -2. It's not 7 minus 5. It's the top minus the bottom, right? Right? It's got to be a small number because the bigger number is on the bottom. You need a fraction, not a big number, right? In both these cases, the bigger number was on the bottom. That's why they had a negative exponent. Right? This is just 1.06 times 3. 6 is 18. 0, 1. Move the decimal twice. 1.18 times 10 to the -5th. Here, we have to do a little work here. 3.2 times 1.8. 8 times 2 is 16. 8 times 3 is 24 plus 1 is 25. 1 times 32 is 32. 875. Move the decimal twice. I'm getting 5.78. Sorry that I ran out of room there. 7 plus -12, right? So here we're adding the exponents, right? Here, when we were dividing, we subtracted them. And so times 10 to the -5th. That is a small number. This is a big number times a small number, and this one turned out to be very small. Okay, so let's do these. So x squared stays where it is. Y to the first stays where it is. That x to the -3rd comes down here and becomes x cubed. That y to the -4th goes up there and becomes y to the 4th. And we get y to the 5th over x to the 5th. Here we simplify 3/6 to 1/2. And so we get a 2 on the bottom. We have this x to the -5th that has to come down here, but then this x to the -7th has to go up there. This y to the 1st stays, and this comes down here and becomes y squared. So we have x to the 7th over 2x to the 5th y cubed. Oh no, I'm done. I'm being silly. These have to cross out and make that a 2. So let me simplify that. Erase, and we get x squared over 2y cubed. Yeah, you're never going to have x's or y's in both the numerator and the denominator in these, right? You add those up, you get x to the -8th, but you have to do the reciprocal, which is 1 over x to the 8th. Positive exponents in your answer. Right, 7 times -2, -14. That's a negative coefficient. That's perfectly okay. X to the -4th times x to the -3rd, x to the -7th, y squared times y to the -3rd. 2 plus -3 is -1. The -14 stays up top, right? Because that's up top. The x comes down here. The y's come down here. -14 over x to the 7th y. Scientific, we're multiplying scientific notation. 2 times 3.4 is 6.8. -5 plus -4, -9. Multiplying powers, right? We're multiplying powers. You add the exponents, whether they're scientific notation powers or regular powers. When you divide powers, we actually divide the 7 divided by 2. 6 divided by 2 is 3. So 7 divided by 2 is 3.5. And we're going to subtract this. All right, so -2 minus 7, which is -9, right? If you flip that, you would get 10 to the 9th in the denominator. All right, so again, this is one of those question mark problems, right? The 3 and 6 part's already been done for you. Oh, this is the one we just did. I feel like are very close to it. And so how are we going to get, we have y over there. We just have to look at these y's over y, and then we have to get a y cubed down here. So what's going to make a y cubed? The question mark has to be -2, because that's -2. Then it'll come down and make the y cubed. All right. Good luck with your homework.